Now we're going to learn how to find the roots of the polynomial using the remainder theorem and the factor root theorem. Now in finding roots of polynomials of this form, you need to know how to solve linear equation, quadratic equation, and the factoring techniques for some polynomials. And the most important skill that you need to use to be able to use this method is synthetic division. Now, in a polynomial, we know that we have the leading coefficients and the degree of the polynomials, and you should know how to identify these terminologies so you can find the roots of our polynomial using this technique. Now, for example, we have a polynomial of degree 5. Our leading coefficient for this particular function is -2 with a degree of 5. And this is important because we know that the degree of polynomial dictates how many or the maximum number of roots that we can have in that particular function. So in this function of degree 5, we know that we could have at most 3 solutions or 3 points of intersection of this graph on the x-axis. Now the second polynomial is a cubic polynomial, and its leading term is at 1 and its degree is 3. Now we are going to be using the leading term and the degree in our method in finding the roots of a polynomial in a little while. Now for our third polynomial, we have 14, which is a constant, but we know that the leading coefficient of a constant is 14 and its degree is 0 because technically 14 is or can be written as 14x raised to 0, and x raised to 0 is just 1. That is why we can have a leading coefficient of 14 and a degree of 0 for this particular constant. Now by factoring, just like in our previous lesson, finding the roots and the solutions of polynomial by factoring technique is limited because not all polynomials are factorable. Now, say for example, our function is x to the fourth minus x cubed minus 2x squared. We know that we can factor this polynomial completely by using the greatest common factor of x squared and using the difference of two squares for the quadratic equation factoring technique to be able to find the factors of this particular fourth degree polynomial. So if we're going to factor this out completely, we'll have x squared times x plus 1 times x minus 2. Now these factors using the zero product property is easy to solve because we have a factorable polynomial for this example, leading us to the roots of the polynomial using the zero product property. So if we have x squared, x plus 1, and x minus 2 as our factors, we can equate each of these factors to 0 so we can solve for x. So the first factor would be 0, the other factor will be -1, and the other factor will be 2 using or by solving for the values of x. Now we know that if we graph this polynomial of degree 4 using, let's say, a graphing calculator, we will see that our polynomial has 3 roots even though it has a degree 4 polynomial, because one of the roots is actually, or one of the vertex or one of the vertices of the root is on the x-axis. So that is why we are only seeing 3 roots when we're supposed to expect at most 4 roots for this polynomial. Now, factoring is or can be used for polynomials or some polynomials that are factorable, but the limitation of this is that in some cases, like if we encounter polynomials like the examples that you are seeing now in the screen, we know that these polynomials are not factorable, and if this polynomial is not factorable, we'll be using a different technique in finding the roots or the point of intersection of these polynomials using algebra, and we call them as the remainder theorem and the factor root theorem. Now we'll start with the remainder theorem. Now according to the remainder theorem, if we have a polynomial and it's divided by x minus c, the remainder, which is going to be found using synthetic division or long division, would be the value of our f of c. So for example, we have a function x cubed minus 3x squared plus x minus 2, and we're going to use the remainder theorem to find the value of f of -3. Now with this theorem, all we need to do is to use synthetic division and to see what our remainder will be. if our function or x is equal to negative 3. So we will use negative 3 as our divisor, and the coefficients for our polynomial, which are 1, negative 3, 1, and negative 2, are the coefficients that we are going to use for our synthetic division. Now, from our previous lesson, you've learned how to use synthetic division already. So all we have to do is to bring down 1 and multiply it with our divisor, which is negative 3, which will give us negative 3. And then we will combine this to our second coefficient, and negative 3 minus 3 is equal to negative 6. So negative 6 is the new number that we're going to use for our synthetic division, and we're just going to repeat the step until we finish our coefficients at negative 2. So negative 6 times negative 3 is 18. Combining them is equal to 19. And then you multiply it again to the divisor, which gives us negative 57. And negative 2 minus 57 is equal to negative 59. So our last term using our synthetic division will be our remainder, and according to the remainder theorem, the remainder of your function will be the value of your f of c, and in this case f of c is f of negative 3. And since the remainder is negative 59, therefore f of negative 3 is equal to negative 59, which means if we substitute the value of negative 3 to f of x, it will give us negative 59 if you want to verify it. But using the remainder theorem, we know that f of negative 3 is equal to negative 59. Now, using the factor theorem, this is basically using the remainder theorem in another level, because here we'll be able to find the solutions or the roots of a polynomial by applying the remainder theorem. Now, the factor theorem gives us two statements wherein if f of c is equal to 0, then the factor f of x or x minus c can be considered as one of the factors of our function f of x. Now, the theorem may be a little bit complex to most of you, but if you use this in a concrete example, it's actually really easy to understand. Say, for example, we have a function 2x cubed plus x squared minus 5x plus 2, and we need to show that x plus 2 is a factor of our polynomial function. According to the factor theorem, which is the two statement that we just had a while ago, if our factor, or if one of the factor is going to give us a remainder of 0 after using synthetic division, therefore we are verifying that that factor is indeed a solution of the 0 of our function. So let's try it out for x plus 2. So by using synthetic division, if we equate x plus 2 to 0, we'll get x is equal to negative 2. So we will use x equal to negative 2 as our divisor, which is the root of the polynomial that we are working on right now, and check if this will equal to 0 if or the remainder is equal to 0 if we divide them. So using the coefficient, which is 2, 1, negative 5, and 2 for our f of x, let's verify if we'll have a remainder of 0 after using a synthetic division. So bringing down 2 and multiplying with negative 2, we'll have negative 4. Combining it with the second term, which is 1, will give us negative 3. And then negative 3 multiplied by negative 2 is positive 6. And combining them will give us 1. And multiplying it again with our divisor will give us a remainder of 0. This means that we have verified that x plus 2 is one of the factors of our function, which means x equal to negative 2 is a solution or one of the solutions of our function. So with this factor theorem, we're able to verify if one of the factors of our polynomial can be the root or the solution of our function. Now let's say we're going to be using the same function and verify if x plus 1 is also a factor of this polynomial function. Now using synthetic division, we're going to try it out with negative 1 this time, because x plus 1 equals 0 will give us a 0 or root of x equal to 1. And by using synthetic division, 2 times negative 1 is negative 2. Combining them will give us negative 1. Multiplying it again and combining it will give us negative 4. And you will notice that this time at x plus 1, or at x equal to negative 1, the remainder of our function is now 6, which means that x plus 1 is not a factor of our function. So this is how we use the factor theorem to verify if the given divisor is considered to be one of the factors of the polynomial. So by using this method, we'll be able to find the possible roots of our polynomial by using synthetic division. Now let's have a new example and see if we can find, or we'll be able to find, all the possible solutions of this polynomial using the factor theorem. Now in this particular example, the challenge is to find the possible roots. Since we know that this is a cubic function because the degree of the polynomial is 3, we'll be able to find a maximum of 3 roots for this particular polynomial if we're going to solve this correctly. Now in solving for this polynomial, all we need to do is to use the factor theorem to find the 3 roots, possible 3 roots of this polynomial. Now since we don't have any clue as to where to begin our solution in finding its roots, we're going to be using a trial and error method in this particular problem. So the first step is to find the first clue of our solutions for this polynomial is to list down all the possible candidates of our solutions. And to be able to do that, we'll be using the leading term and the last term of our polynomial, which is 2 and 3. So from our leading term and our constant term, which is 2 and 3, we will produce the candidates by finding all the factors of 2 and 3. For the factors of 2, we'll have 1, -1, 2, and -2. And for 3, we'll have 1, -1, 3, and -3. Now these numbers are our clues as to which of them will give us the roots of our function 2x cubed plus 3x squared minus 8x plus 3. So how are we going to use all these roots to use or to find our solutions for this polynomial? We will be using synthetic division to verify if our solution or if our candidates will give us a 0 if we use synthetic division, or a remainder of 0 if we use synthetic division for this particular candidates. So the possible solutions of this function or cubic function could be x equal to -1, or x equal to 1, or x equal to 2, -2, 3, or -3. Now since this is a cubic function, we know that we are expected to find only 3 solutions at the most as the roots of this polynomial. So we're going to start our trial and error using the first root, which is -1. So as -1 is our divisor, we will be using the coefficient of our function to use synthetic division. Now let's see if -1 will give us a remainder of 0, so we can choose -1 as one of the solutions of our polynomial. So using synthetic division, we would see in this particular value of x, which is -1, we have a remainder of 12, which means our remainder is not 0, so -1 is not a solution of our polynomial because it's not giving us a remainder of 0. So we're going to use the other candidate, which is +1, and hope that this time we'll get a 0 as our remainder. So using the coefficients and synthetic division, let's see if it will give us a remainder of 0. Now at x equal to 1, which is one of the candidates of our solutions, you are seeing that our remainder is 0, which means one of the solutions of our cubic function is at x equal to 1. Now the only thing that we need to figure out is the other 2 solutions that we would have in finding or in using the factor root theorem. And to find the solution of this factor root theorem using 2, 5, -3 as our coefficient, we're going to transform this into a quadratic function, giving us 2x squared plus 5x minus 3 equal to 0. And now that we have a quadratic equation, we can use the quadratic formula or factoring method or completing the square method to find the roots or the solutions of this quadratic equation. Now, since this quadratic equation is factorable, we'll use factoring technique in finding the other two solutions of our cubic function. And the factors of 2x squared plus 5x minus 3 will give us 2x minus 1 and x plus 3 as our factors. And using the zero product property, by equating the factors to 0, we'll be able to produce the solutions of the quadratic equation from our synthetic division. So the two solutions of our quadratic equation from the first synthetic division that we did would be x equal to 1/2 and x equal to -3. Which means, by using the factor or the factor root theorem for the first root of our polynomial, we're able to see or find that 1 or x equal to 1 is our solution, and using factoring method of quadratic equation, we're able to produce the other two solutions, which is 1/2 x or 1/2 and -3. So using this method, we're able to produce the three solutions of our non-factorable cubic function using the factor theorem.